Welcome you all for the session. So in this session we are going to discuss about the introduction to 8085 microprocessor. So the expected outcome from after completion of this session is the student should able to explain the features of 8085 microprocessor. A microprocessor is a multi-purpose programmable clock-driven register-based electronic device that reads binary instructions from storage device called memory, accepts binary data as input and processes data according to those instructions, and provides results as output. So here uh, you can see the basic block diagram of a microprocessor, and it is associated with the memory and the I/O devices. Evaluation of microprocessor. So in 1971, the first microprocessor was introduced. It was 4004. It has a word length of 4-bit and a memory capacity of 1 kilobyte. It is made up of a 16 pins package and the clock speed is around 750 kilohertz. Later in 1976, the second microprocessor, that is 8085, was introduced, and it is an 8-bit processor. It's a basic processor, and in this course we'll be studying in depth about 8085 microprocessor. The clock speed of this processor is around 3 to 6 megahertz, and here it is a 40 pin package. Again, later in 1978, the 16-bit processor 8086 was introduced, and the memory capacity is improved to 1 megabyte. And here again it is a 40 pin package with a clock speed of 5 to 10 megahertz. Later in 1980s, the next processor, which is 8088, was introduced. Again it is a 40 pin package with a clock speed of 5 to 8 megahertz. Later in 1982, the processor 808628 was introduced, and which has a memory capacity of 16 megabytes, and the pin is 68 pin package. Here the clock speed is improved to 6 to 12.5 megahertz. Later in 1993, Pentium processor was introduced with a clock speed of 60 to 200 megahertz. Later, Pentium Pro was an advanced version of Pentium, that is Pentium Pro was introduced in the year 1995 with the word length of 32 bytes with the speed of 150 to 200 megahertz. And later, Indium processor was introduced in the year 2001 with a 64-bit word length, and here the speed of clock is improved to 733 megahertz to 1.5 gigahertz. So again and again I am repeating a word length in the processor. The word length of microprocessor or a computer is given as n byte, where n is 4, 8, 16, 32 or 64. An 8-bit microprocessor can process 8-bit data at a time. Its ALU is of 8-bit. The general purpose registers which holds the data for processing are 8-bit. Similarly, if we are going to use a 16-bit processor, means the word length will be 16-bit and the ALU will be of 16-bit. So it goes on. So the processor of longer word length is more powerful and can process data as fast as. So how now we are going to see how a microprocessor system will be. This is the basic structure of a microprocessor. So here we have a microprocessor, that is the CPU. Then we have some interfacing chip. With the help of this interfacing chip, we'll be interfacing the ROM memory devices, IO device, memory device. These are all the peripheral devices. The devices which we can interface with the processor, we call them as the peripheral devices. So here you can see the various buses. the three buses are there in the bus system. Here you can see the first one is the address bus, second one the data bus, and the third one the control bus. So now we are going to discuss about the central processing unit or the CPU. So the CPU consists of ALU, a register unit, and a control unit. So let's discuss what is ALU, arithmetic and logic unit. This session performs computing functions on data. These functions are arithmetic operations such as addition, subtraction, and logical operations such as AND or rotate, etc. The results are stored either in registers or in memory or in output devices. Most probably, most of the time, in 8085 processor, the result will be stored in the accumulator. Then the second block is the register unit. It consists of various registers. The registers are used primarily to store data temporarily during the execution of program. Some of registers are accessible to use through the instructions. Control unit. It provides necessary timing and control signals necessary to all operations in the microcomputer. It controls the flow of data between the processor and peripherals. The control unit gets a clock which determines the speed of the processor. Next comes the bus system in 8085 processor. So the first bus is the address bus. It is a group of wires or lines that are used to transfer address of memory or I/O devices. It is unidirectional. In Intel 8085 processor, address bus was a 16-bit. This means the microprocessor can transfer maximum 16-bit address, which means it can address 65,535 different memory locations, that is 64 kilobytes. That is why we call it has an address of, it can able to address up to 64 kilobytes. This bus is multiplexed with 8-bit data bus. So the most significant bit of address goes to the address bus A7 to A0, and the least significant goes to the multiplex data bus AD0 to AD7. Next comes the data bus. The data bus is used to transfer data within the microprocessor and memory. It is bidirectional as microprocessor requires to send or receive data. The data bus also works as address bus when multiplexed with lower order address bus. Data bus is 8-bit long. The word length of processor depends on data bus. That's why Intel 8085 is called a 8-bit microprocessor because it have an 8-bit data bus. Next comes the control bus. Microprocessor use control bus to process data, that is what to do with the selected memory location. Some control signals are read, write, opcode fetch, etc. Various operations are performed by microprocessor with the help of control bus. It is dedicated bus. This is a dedicated bus because all timing signals are generated according to the control signal. The microprocessor is the master which controls all activities of the system. The program consists of a set of instructions stored in consecutive memory locations one by one. So in order to execute the program, the microprocessor issues address and control signals to fetch the instruction and data from memory one by one. After fetching each instruction, it decodes the instructions and carry out the task specified by the instruction. Memory. To execute a program, the user enters its instructions in binary format into the memory. The microprocessor then reads these instructions and whatever data is needed from the memory, executes the instructions and plays the results either in memory or produce it on the output device. Thank you.